Hi, this is day 25 of trimester 2, more fencing problems. Today we're just going to continue on with the maximum problems that we started yesterday, and I have 4 examples today that just build on what we did yesterday. So again, we want to make sure we show all our work and we justify our answers, which means showing our sign chart. Farmer Brown has, for problem number 1, Farmer Brown has 80 feet of fence with which he plans to enclose a rectangular pen along one side of a 100-foot barn, as shown in the figure below. The side along the barn needs no fence. What are the dimensions of the pen that has the maximum area? Okay, so a couple things to consider going back into what we just saw in the problem itself. We said he has 80 feet of fence. So with that 80 feet of fence, he has to enclose 2 X's. He has to have 2 sides and a length, and he has 80 feet of fence in which to do that with. He doesn't have to put fence along the barn, and we're going to assume, we don't have to assume how long the barn is. We know that the barn is 100 feet long. So we've got plenty of fencing. That even if you stretch the fence out just along the edge, we have 80 feet, which is not as long as the barn is. So we want to then look at, well, what are we doing here? We want to maximize the area. If we're going to maximize area, we need an area equation. So let's even just give ourselves that little hint here that we're maximizing area. So the area, it's a rectangle, so it's length times width. Yesterday we said we didn't want to have that many variables. And in this case, I've got variables labeled as x's and y's. So let's go ahead and change that to x times y. So we're using the same variables as we have in our problem. But still, too many variables, so I'm going to come back over to this equation, my perimeter equation, and say, well, all right, I can see that y is equal to 80 minus 2x. So we'll come back and substitute over here that a equals x times 80 minus 2x. And because I'm going to need to take a derivative, I'd rather not have to use the product rule, so I'm going to distribute, and I have 80x minus 2x squared. Nice straightforward derivative. A prime equals 80 minus 4x. Again, like yesterday, it came out with a nice linear equation that makes us happy. We're going to set that equal to 0. So I have 80 minus 4x equals 0. 4x equals 80, or x equals 20 feet. Well, I'm hoping that that's a maximum. We'll come back to our sign chart and say, okay, well, here's my a prime. Here's my key value of 80 feet. This is a linear equation. It goes downhill, so I've got positive values here, 0, negative values, uphill, downhill. Yes, that's a maximum. That's what we're looking for. Makes us happy. So our length, our width is 20 feet. So our y value, our length, must be 80 minus 2x is 80 minus 2 times 20, and that makes it 40 feet. So our area, again, being length times width, is 20 times 40 is 800 square feet. Nice warm-up problem for the day. Again, organizing our stuff. Farmer Brown now decides to make 3 identical pens with his 80 feet of fence. So he still only has 80 feet, but he wants to keep his animals separate now. Evidently, they're not getting along. He needs to keep them separate, so he's going to have his goats, his sheep, and his pig, as shown in the figure below. Again, we aren't going to need to have any fence up against this barn wall because we've got the barn to keep them confined. What dimensions for the total enclosure make the area of the 3 pens, make the area of the pens as large as possible. Okay, so we're going to say that this entire length is y, but each one of these dividers is an x. So in order to make this enclosure, we're going to have 4 x's and a y all coming from that 80 feet of fence. We're going to be maximizing our area, large as possible, the area as large as possible, so I need area equals L times length times width, or in this case is X times Y. So coming back over here, Y is equal to 80 minus 4X, so I can substitute from that. I have A equals X times 80 minus 4X, distributing so that I can take my derivative more easily, 80x minus 4x squared. Taking the derivative, A prime equals 80 minus 8x. I always put a box around these because that's the equation I'm going to be using for my sign chart, and I want to be able to find it. So it's just helpful that if I've got a whole lot of work to support an answer, I want to know, well, okay, so where is the answer when I want to come back and use that. So as always, I'm going to set this equal to 0 because we know that a maximum or a minimum takes place where the derivative is equal to 0, either at the top of a crest or the bottom of a gully. So 80 minus 8x equals 0, 8x equals 80, x equals 10 feet. Make sure that this is in fact the maximum that we're looking for. So I've got my 10 feet. I've got a linear equation headed downhill, so positive, 0, negative, uphill, downhill. This is a max. That's what I'm looking for. Makes me happy. So my x is 10 feet and y equals 80 minus 4x. Y equals 80 minus 4 times 10. 80 minus 40. Y equals 40 feet. So my area equals x times y equals 10 times 40 equals 400 square feet. So clearly less overall space for his animals than he had if he just made one big pen, but he had to use some of his fencing for these dividers. Now, suppose that Farmer Brown has 180 feet of fence, more fence this time, and wants the pen to adjoin to the whole side of the barn. We want to use the entire side of the barn as shown in the figure below. Now, what are some of the reasons why the farmer might want to do that? Well, maybe there's gateways out of the barn, and he wants to make sure that all of those gates end up going into the pen. There could be all kinds of reasons why we would want to design our pen that way. So as shown in the figure below, what would be the dimensions for the maximum area? So again, we are maximizing area. I'm going to come back to this note. I'm going to kind of ignore that's there for right now. I do want to remember, though, that I was told initially back in the first part of the problem that his barn is 100 feet long. Got to keep track of that. So if Farmer Brown wants to make this pen, we know that this side, if it's a rectangle, is also going to be x. This small piece, though, right here, is going to be the entire y minus this 100 from the barn. So the entire length y minus the 100 that we don't have to put fence on because the barn is making that side of the enclosure. So if I'm going to be making my, using my 180 feet to make this pen, I'm going to have two x's. Those are my two widths. I'm going to have a y for this entire length, and I'm going to have this y minus 100 that will all take up the 180 feet of fence. And simplifying that, I've got 2x, I've got 2y, minus 100 equals 180, and simplifying some more, 2x plus 2y, add the 100 to each side, equals 280. And while I'm simplifying, x plus y equals 140. Well, now every time that we've done this, we have ended up using a substitution. I'm not going to solve for one of the variables yet. See if there's some reason why one variable makes more sense than the other. So coming over here, we know that we want to maximize area. So we need an area equation. It's going to be that width times the length of the entire pen. So yes, I do need to substitute because I've got too many variables here. And let's get rid of y. Y is equal to 140 minus x. So a equals x times 140 minus x. Distributing only to make our derivative easier. 140x minus x squared. Taking the derivative, a prime is equal to 140 minus 2x. We're going to set that equal to 0. So 140 minus 2x equals 0. 2x equals 140. X equals 70. Okay, we set it equal to 0 because we're looking for a maximum or a minimum, where the derivative is equal to 0. So that's equal to 70 feet. Well, now let's come back up to this. It said x needs to be between 0 and 40. Well, why is that? Well, it needs to be between 0 and 40 because if the x being bigger than 0 makes perfect sense. That if x isn't a positive number, if it isn't something greater than 0, we don't have any pen. It's got to have some kind of a width. But x being less than 40, we need to come at it from a little bit different angle. And that is that we were told that the pen needed to use up the whole side of the barn. That means that y has to be greater than or equal to 100 feet. If y is greater than or equal to 100 feet, let's just say we take up 100 feet of the barn, of the fence. If I've used 100 of my 180 feet, then that leaves me 40 feet for my y's. I'm sorry, that leaves me 80 feet for my x's. Cut that in half, and that's 40 feet for each one of the x's. So let me just write that out. Now we have 180 feet of fence. If I only take 100 feet of it for the y, that leaves me with 80 feet. If I take the 80 feet and divide that into two pieces, because I've got to have an x on each end, that leaves me with at most 40 feet for the sides of the pen. Algebraically, we can also say, well, if y is greater than or equal to 100, and we know from down here that y is equal to 140 minus x, algebraically we can solve that. We can say negative x is less than or equal to negative 40, or x is less than or equal to 40. Divide each side by negative 1, make sure we switch the direction of that inequality arrow. So we have x has to be greater than or equal to 0, less than or equal to 40. And since the equal to 0 doesn't make any sense, we're going to say that x has to be greater than 0. But I would say that it could equal 40, so I would put an equals underneath there. So this 70 doesn't work. It's not between 0 and 40. But let's look at our sign chart. Now, that's where we've gone every time. If we take our sign chart and say, all right, well, here's my derivative I'm looking at. My key value is 70. This is a linear equation with a negative slope. So these are positive, 0, negative, uphill, downhill. This is the max that we wanted. But we're now told that x has to be between 0 and 40. So we're going to come over here, and here's 0, here's 40, and say, okay, well, 0 and 40, the higher of these two, the area when x equals 40 is as big as we're going to get. So we're going to let x equal 40, which means that if y is 140 minus x, y must be 100. So x is 40 feet, y is 100 feet, and our area is equal to 40 times 100 is equal to 4,000 square feet. So our diagram was deceptive. It looks like it extends out beyond the barn, and we need to draw it that way, that it could have gone out beyond the barn. We could have had some amount of fencing out here. But as it turns out, we're going to maximize the area if we just use the length of the barn and come out as far as we can. So 100 by 40. For this last problem, we're going to be taking in all of the stuff that we've done above. We still have our barn. And now he decides to use, he only has 80 feet of fence this time. He's going to make a rectangular enclosure. That's this enclosure, the clear part, to fit in a 20-foot by 40-foot corner of the barn. So the barn has been built with its notch cut out of it. And he wants the pen to come out from that. So perhaps he has some gateways coming out from the side of the barn, some barn doors. And along the barn isn't going to require a fence. So what dimensions give the pen the maximum area? So again, we're going to be maximizing area. So max area. And the area of this is x times y. But over here, if this side is y, and we've used on the opposite side from y, 40 feet of this length is made up by the barn. This length must be y minus 40. Similarly, if this entire length is x, this length must be x minus the 20. The 20 being the side of the barn that is 20 feet long. So our entire pen is made up of this y, this x, this y minus 40, and this x minus 20 is the 80 feet of fence that Farmer Brown has. So collecting our like terms, we've got two y's, we have two x's, we have minus 60 equals 180, add the 60 to each side, and we have, or not 180, equal to 80. We had 180 feet last time. Equals 140, or y plus x equals 70. And we can see over here that we are going to need to do a substitution, so we'll say that y equals 70 minus x. Important equation. So come over here with our the equation that we're going to want to maximize, and we'll use the substitution that x equals, or a equals x times 70 minus x. Distribute. A equals 70x minus x squared. We know we need to take a derivative. A equals 70 minus 2x. Because we want a maximum or a minimum, we're going to set that equal to 0. 70 minus 2x equals 0. 2x equals 70. X equals 35 feet. Okay, so we make our sign chart with 35 feet. These are our x values for our A prime. And this is a linear equation going downhill. So we have positive, negative, maximum. That's what we're looking for. But we've got some restrictions over here. We need to make sure that we are filling in this entire side of the barn. And the problem asked us to start with the hint. I decided not to, obviously. But let's consider these restrictions now. We know that if we need to fill in this entire side of the barn, that this length x needs to be greater than 20. Greater than or equal to. We also know that y is going to need to be greater than or equal to 40. Because we need to fill in this entire side. So our restrictions on x, and x being the variable that we chose to use, we chose to keep x's in here and get rid of our y's, we know that x needs to be greater than or equal to 20, but it needs to be less than or equal to what? Well, we could go back and do the intuitive reasoning on what was the smaller, the largest that x can be. But let's look at it algebraically. We have this substitution equation. If y needs to be greater than or equal to 40, and y is 70 minus x, let's substitute again with that 70 minus x is greater than or equal to 40. Subtract the 70, and we've got negative x is greater than or equal to negative 30. Divide each side by negative 1, and x is less than or equal to 30. So we've got x is between 20 and 30. Coming back up here to our sign chart, if x needs to be between 20 and 30, where is it larger? Or where is it largest between 20 and 30? Well, right here, when x is 30. So we're going to let x equal 30 feet. And if x equals 30 feet, y is 70 minus x. Y is 70 minus 30. Y equals 40 feet. And our area equals 30 times 40 equals 1,200 square feet. So as it turns out, our y value at 40 feet, our pen is really going to look more like this than as we drew it in our initial sketch. So, as always, hope this helps.